Hey guys, welcome back to this old signal generator. I'm going to be taking a look at the HP 606A again for two reasons. One, as some of you pointed out, that is not the original band switch knob. I probably should have realized that in hindsight. One, because it doesn't match the other knobs. Two, because I do know where that goes. I just wasn't thinking straight. And this also solves a bit of a mystery because when I got this generator, this knob had a wire threaded through it and it was tied to one of the carrying handles. Notice this knob matches the same styling as these function knobs. This is the original band switch knob that would have gone right here. Now, why was it replaced? Well, if you recall, I was struggling, and still am struggling, to change the bands. So, I think the previous owner was starting to have more and more difficulty changing bands, so rather than fixing the problem, he put on a larger diameter knob, which will give you more torque. Well, this knob goes to a Collins receiver. I got two of them. We'll be showing them in a future video. One of them, I noticed, did not have the original band switch. It had a rather odd looking big round knob that says Ohmite on it. Well, this is the knob from that receiver. So we're going to be taking this knob off. I'll give it to my buddy who currently owns that receiver. I kept one for myself and gave the other one to him. And we're going to be putting this knob on. And we're going to be opening this up and delving in where I dared not go before, which is inside the box. Because luckily, there's another YouTuber who made a video where his band switch was completely frozen, or range switch, I guess they call it. His range switch was completely frozen because his generator had sat for years, and he had to go into that box. And I see now that there are bearing points buried behind this assembly that we have to lubricate. So I was just looking at the gears before, or the part that was accessible from the outside, and there were some mechanisms there, but there's a lot more going on behind it, so we're going to lubricate everything. What we're also going to do is take a look at what is on top of this. Like I teased in the previous video that I had another frequency counter that was very cool. That would be this. It's a Beckman 6401. Why is this cool, or why do I think this will be cool, assuming it powers up? Because it has Nixie tubes in it. 1, 2, 3, 4, 5, 6, 7, 8, at least 9 Nixie tubes in there. One for each digit, and probably one to indicate mode or some such. This takes an oddball power cord connector on the back, so I have not tried powering this up. However, this came from the same estate as these other devices I've been showing you, and he kept very good care of things, and I suspect this works just fine. I have the manual for it. If we need to, we'll just temporarily tack in a power cord so we can get this sucker going. We're also going to take a look inside of it because this is the early days of solid-state electronics, so there's a lot going on in here to drive just some digits. So now, if you haven't seen the other video, or I'll just refresh your memory, the problem is this doesn't work so well. So I can turn it, and there's resistance. You know, it springs back. It's not changing. I have to crank on it, give it a lot of force. It still didn't change. There we go. It may still not be working. Sometimes I had to kind of jiggle it a little to get everything to lock in. You'll see inside why. There's a lot going on behind this. There are several decks, I believe, of capacitors and inductors and such that are changing over. I believe part of it is to set the internal oscillator. I think there's also some filter components to it, and there's a whole bunch of stuff being switched in and out as you change this range. I removed the cover from the 606 again, and I'm working on taking off this RF shield. Now, luckily they do include this very long Allen wrench, because you will need it. Along the more accessible edges they use Phillips head machine screws, but down here in between power supply and the audio oscillator area and this shield, there's only about a half-inch gap, and you will need this long tool to get down in there. One more screw to get out. It should come off. So this is shielded for a good reason, not only to block RF, but also keep dust and debris and fingers out of all this intricate mechanism. So there's this huge gear that is for the frequency control that goes through this cast metal piece. I assume there's bearings in there. And then it goes to this drive mechanism and rotates these variable caps. Check this out. Is some nice action. So where is the band switch? Well, that's on the other side. Let me flip this around and show you. Wow, check this out. There's not one, but two huge tooth gears with capacitors and inductors mounted all around. Those would be your different frequency bands. And boy, yeah, I could see, even with the great lubrication, man, it's a lot of stuff to move around. So, good chunk. Wow. So here's the ka-chunk mechanism, that roller wheel, and tension on that. There's got to be some other tension coming from somewhere though. Okay, yeah, I see it. There's a spring back in there. There's a heavy piece of wire. Kind of picks up some tension. So that goes over. So I'm going to get a needle oiler. I'm going to oil up all these bearing points, and especially I want to get some oil down in there and down in there, while not touching anything else. I don't dare want to brush against any of this stuff. I don't want to disturb anything because it's working so nicely. Let me check this out though. I noticed some of the screws had some Mars on them, so this had been opened up, and fairly recently. I'm assuming that means 2013. This 12AT7 was replaced with a 6201. I'm going to assume that's the ruggedized version of it. Some other tubes up here. Some 12B4, 68W8, 6CL6, 12AT7. Got an electrolytic here, some mica caps. So yeah, if I wanted to go through and recap this should probably be replaced. Well, there are already paper caps in this. I think this is new enough. They introduced this in '59. That made it through the '60s into the '70s, I believe. There was a B and maybe a C version. And this is either a later build or it was modified, because the original one did not have the solid state crystal reference oscillator down here and had tubes. This one is all transistor. Alright, let's get to lubricating and see if I can get this action any smoother. I put oil and light grease in everywhere that it seemed like I could safely put some in. And I also noticed there are several holes. It looked like oiler replaces the feed-in oil. One here, one here, and one here. So I did put some light machine oil in there, and then some grease on top of that. By grease, I'm actually talking about this Lubriplate 105 stuff, which is light grease. Kind of has some oil mixed in with it too. It's kind of my go-to for everything. So I lubed up this mechanism. I put the original knob back on. Put grease on all movable surfaces, gears, and whatnot, and it's better. But I think the reality is you're turning a lot of stuff, including all the way down to this switch way over here. So, yeah, I think even in the best of circumstances, it takes a bit of force. But it definitely is better than it was. Occasionally that little roller wheel doesn't drop quite into place, and you gotta kind of just jiggle the knob a little bit. But the more I use it, the better it seems to be working. So I think this operation was a success. What seemed to especially help is getting grease around this locking washer down in here. And there's another one behind this mechanism down in there. I put some grease in with a toothpick and kind of worked it around those. I forget what you call them, locking washer thingies. I know they're not cotter pins, but or something like that. Snap rings, maybe. I don't know. You know what I mean. Yeah, cool. So, yeah, back to the original knob configuration. And the knob that I took off can go back onto the Collins receiver. Alright, now it's time to clean up any extra grease I slopped around in there. Put everything back together. Also notice, as one of my viewers, or maybe more than one of my viewers pointed out, this is rack mountable. And that's why it had kind of an odd way of attaching to the cabinet, is that it's also can be put into a rack, and I seem to be accumulating more and more rack equipment, so it might be time to think about getting a mini rack cabinet for the workbench, because boy, I have 3 Hewlett-Packard RF generators now that are all rack mountable. I have several power supplies, yeah, and a few other things, so that's something to think about. The 606A is all back together. I'm going to turn it on. I've attached the output of it via BNC cable to the Beckman. Now the Beckman has an odd power connector on the back. I'll show you in a moment. For now, I just tacked in a line cord so I can try powering this thing up. I have not turned it on before, so I don't entirely know what's going to happen, but let's give it a try. Okay, well, that's a good thing, I think. Although it seems to be stuck on 7 plus a bunch of 9s. Let's see. Let's put the mode on well, want all zeros. Time base 0.1 seconds. That seems right. Change the sensitivity. It seems to be counting away like mad. Give you guys a little bit closer look here. That's pretty trippy. It seems to just be counting as fast as it can like crazy. I'll go to a 1 second time base. Now I've got the RF generator tuned into about 455 kilohertz, and we're on kilohertz, and it looks like it's counting up to around 4 something, and then it resets. So it seems like it's counting for 1 second, and then resetting and continuing to go. Normally with a frequency counter, it'll be counting behind the scenes, and it just shows you the final result. You don't actually get to see the active counting process, so that's kind of weird. Let's see, what does burst mode do? It doesn't seem to be a whole lot different. as test mode. Looks like that just counts. Standard frequency, and there is display time. Right now it's on minimum. So I'll toggle switch here. There's 3 positions: minimum, hold, and variable. Let's see, I'll do hold. Interesting. 4549999. Wow, that's pretty darn close to 455. Seeing if I do reset. Oh, that's cool. Put a little bit more light so you can see what the heck I'm doing. I guess we'll go with that. Alright, so what I'm doing is I'm pushing this reset button, and then it counts to that, and then it stops. So it's counting for 1 second. Let's see, if we do 0.1 second. Yep. And let's do 10 seconds, because why not? We can test all the digits. So it's cool. I've never seen a counter that actually shows you in real time while it's counting. It's kind of pointless unless you had a really, really low frequency. The last digits are all just a blur, so kind of meaningless. Alright, so that's hold where we get 1 shot. Let's see, reset goes to zeros. And there is a variable. Let's go back to let's see, 1/10 of a second. Oh, interesting. So you can, it's a variable pause of when it starts counting again, or how long it holds off on doing another gate. Alright, so that seems to make the most sense. You'd want to use a setting something like this so it's not a blur. And well, I mean, it sure seems to be working. I'm dialed into 455 on the HP, and this is measuring basically 455. And yes, it is Nixie's, and it is beautiful, a beautiful thing to behold. Although really, your viewing angle does matter, and when depending on the number, like the 4 is pretty deep in there, and they're a little harder to see. So for those of you who don't know, Nixie Tube, there is actually a metal piece cut out in the shape of each of the digits 0 through 9, and they're stacked up inside of a tube filled with neon. So it's kind of like a neon bulb, and which digit gets illuminated is determined by the integrated circuits and the counters and all the electronics inside. Very popular with the clock makers and DIYers, repurposing these things. So a lot of these equipment that use Nixie tubes actually gets scrapped out because people want to take these tubes out, and they sell for a fair bit because, well, they haven't been made in decades, and people like to use them for various projects. A clock being a very, very common one. I kind of prefer to keep the old equipment alive as long as possible. So very cool. It does indeed appear to be working as it should. So let's pop the top and take a look at all the magic inside of this device. No, first let's play around with it a little bit more. I didn't realize this time base kept going, so 1/10 of a second is what I was using. You get a 10 millisecond, 1 millisecond, 0.1 millisecond, and go all the way down to 100 nanoseconds. So, let's see, let's crank up the frequency on the RF generator. Let's go on the highest range. And I am dialed, let's go to 60 megahertz. Can this thing even do that? So I'll try increasing the output Yes, it can. I said to bump the output on the RF generator up a little bit. So 59,406 kilohertz. Or 59 megahertz. So either my HP is off pretty far, because I've got that actually I have it dialed into 60.5 right now, and I'm getting about 60 on the display, or the frequency counter's off. Oh, and we'll get a megahertz if I decrease the time base to 10 microseconds. Seems a little silly since you're only getting, well, if I go all the way, we only get one digit now. Or 2 digits. Alright. Here's a close-up of the back of the unit showing that power interlock that is similar to a modern power cord, but not quite. There are 3 pins that are round rather than the modern rectangular type, so I just don't have anything that would fit in there. I'll have to hunt around online and look at vintage power cords, see if I can find something. Meanwhile, I just tack soldered on a line cord. Not exactly the safest thing to do, but hey, we got the job done. As far as getting this open goes, notice there are some thumb screws on either side. I think you undo these, because I don't see any other fasteners anywhere that you can get access to easily, which seems to loosen up this. Oh, I see. Then just drop. Actually, all you have to do is drop it down. That's interesting. And then the top slide. Yes, top slides off. Very cool. So with those 2 pieces slid down, the whole top panel comes out. And there are all those Nixie tubes and all the chips to drive them. It's crazy. Later on, I think they came out with an LSI type integrated circuit that could combine an awful lot of this functionality into making almost a single chip frequency counter. So these, I believe, are just to drive each of the Nixie tubes. I think they're 7441s. Yeah. Those are TTL driver chips. They can drive a higher voltage and current loads than a normal TTL chip. And let's see. And a bunch of 7490s. Those are decade counters. And I don't recognize some of these Motorola chips. They're not part of the standard 7400 TTL family. Boy, seeing chips as old as 1967 in here. Here it is with the whole top panel removed. Wow, that is one complicated beast. And a lot of that I think has to do with the functions that I'm not that interested in, like doing the period measurements or timer functions. And this can also be controlled remotely. So a lot of this stuff is going to be for that functionality, whereas the heart of the frequency counter is this stuff right here. That's good. I'm not seeing any parts that might be subject to failure, like paper caps or leaky electrolytics or tantalum caps or anything. I'm just seeing some. Well, that's a plastic film cap and a whole bunch of semiconductors. Oh no, there's one tantalum cap, maybe 2. Those, if you're going to be using some vintage type equipment, I suggest you swap those out just for your own peace of mind. Over time, they do age. When they fail as a dead short. Wow. Speaking of failing, sure looks like the top of that ceramic IC is cracked. Huh. It's not like it cracked all the way through though. It looks like just the top piece. So with these old ceramic chips, there's a bottom piece of ceramic, chips inside, bonded out to the pins, and then another piece cemented on top. Looks like that piece cemented on top is what cracked. Huh. Oh, it's not cracked. I'm sorry. That's just the way they're made. Just from the shadow, it looked like a crack, but no, there's a raised area in the middle. What I'm hunting around for are some TTL chips, which I know are in here somewhere. So I was wondering, how can this early TTL device measure up to 125 megahertz? Well, it can't. These old 7490 chips can, I think, only measure up to 10 megahertz or something like that. If you get an S version, maybe they can go up to 25 megahertz, something like that. So I took a brief look at the parts list, and there were some ECL, emitter coupled logic chips. Those can run at much higher frequencies, but they are finicky. There's a price to pay for that speed. They use some oddball voltages, I think minus 5.2 volts. They need special termination. They run really hot. You need to design the circuit boards properly for shielding and to prevent feedback and crosstalk and all kinds of fun stuff. So I'm going to guess it's on a separate board and a separate module somewhere. I think if we flip this whole thing over, there's some more goodies packed away. Here is a look at the bottom. Yes, the bottom cover slides out just like the top did. Not as much to see though. We're seeing the underside of the boards. Power supply. Yes, I do believe this is all gold plating everywhere. Lovely. There is another board hidden down here. I believe this will have that ECL stuff on it. I will endeavor to get at it, but I don't know how. Looks like I can't get at it from the bottom. I'll try from the other side. Not sure what this is for, since power supply's over here. Auxiliary maybe, or maybe it has something to do with this, which is a neat thing, and it is warm. Quite warm. What is this? This is a crystal oven. So this has a time base, and it's a 10 megahertz time base. It's very typical for test equipment, frequency counters in particular. They have a 10 megahertz oscillator. To make them more stable, the nicer higher end ones put the crystal and associated components inside of an oven. Why would you do that? To keep the temperature constant. If you just leave it at ambient temperature, well, ambient temperature is whatever happens to be in your workshop, which could vary quite a bit. This will raise it to, I don't know, 150 Fahrenheit, something around there, I imagine, and keep it there, which helps keep everything very, very stable. There's an opening back here if one should ever need to tweak that to calibrate it. Very nice. On the other side, it looks like this main board covers it from that side, and on this side we have metal. So I don't know if I'm going to be able to take a look at that, but we'll try. Back to the other side. Turns out if you want to take this main board out, you have to take out 2 screws on either side of this connector, and then you have to completely remove that metal piece that was on the end getting in our way, and then slide off a piece of metal here to expose the side panel, and you have to undo a couple screws, which are holding the board in, and you can flip the whole thing out of the way, and there is the other board, which certainly has a high frequency look and feel to it. And I think all the ECL is hiding underneath this ribbon cable. Yes. Good old Motorola 10K or 1000 series of ECL. So MC1013, MC1034, MC102 or 23. It's all ECL stuff, very high frequency stuff. That's what I put on a separate board. Also, all lovely, lovely gold plated. So what'll that do? That'll do your pre-scaling. So this stuff up here, I suspect, is amplifiers, limiters, and whatnot to condition the input signal to feed it into these, which are a series of, I know there's at least some flip-flops in there, which each flip-flop can divide the frequency by 2. And eventually it'll divide it down to a low enough frequency that it can feed into the TTL chips. Here it is back together, and luckily it's still operational. Now I'm left with a bit of a dilemma. Which one do I use? I have this newer one with the beautiful VFD display that works great. A decade newer, maybe. Much smaller, and it can do twice as high a frequency. Versus this, which has the coolness factor of the Nixie tubes. It's harder to read. It takes up a lot more space, draws a lot more power. I'm inclined to go with this guy, and honestly I don't use frequency counters a whole lot. Mostly just to sanity check or to check on calibration and stuff, but generally I use more modern signal generators that are synthesized and pretty darn accurate, so I really don't need to check up on them very often, but they are neat things to have. There's no doubting that. Well, I'll have to see how things go. Also notice that this is kind of rack mount size, but it doesn't have the mounting ears on the side. I expect that was an option, or maybe there was a rack mounting kit you could get. If I could mount this in a rack, I'd be more inclined to get a small rack and take this out of the cabinet and mount it in the rack with the frequency counter, with power supply and some other stuff I have. But the important thing is all this stuff works. And I hope you enjoyed taking a look again inside of the 606A. We got to see inside of the shielded chamber this time and lubricate it, and yes, it is working better. And we got to peer inside of this cool Beckman 6401 programmable counter timer with Nixie tubes from late 60s, I do believe. Thanks for watching.